Hi, in this video I'm gonna show you how to use Excel to solve some of the problems we have before we keep moving on with more content. So I go to Mind tab and I go to chapter 14 and then 14.2 least square method, and then I click here and it opens some applications, some exercises. Maybe if you click on yours you get here. Okay, so if you get here, then you click here, exercise and applications, and take you to where I am. Okay, so I'm going to skip this first one and the second one because I want one that I can download the data. Okay, so let's solve this problem. The NFL records a variety of performance data for the teams. We want to investigate the performance of passing on the percentage of games won by a team. So here's the keywords to investigate the importance of passing. Passing is one of the variables, and percentage of games won by a team are the second variable. The following data show the average number of passing yards per attempt. So this variable is the average number of passing yards per attempt and percentage of games won. Okay. And the first question is which one is the dependent and which one is the independent variable. Think a little bit, but you are going to figure out that the win percentage, the percentage of games won, this variable depends on the number of passing yards. So this is our X variable, this is our Y variable. Okay, it's asking to develop a scatter diagram. So let's download the data. So when you click here, it asks you to download the data. Okay, let's open the data. And let me show you here. So here's the data. Enable editing. So this is the independent, this is the dependent, this is like the two columns they should be. You go to insert, scatter diagram, and there we go. Oops, that's not really what I should have done. So I delete. Let me select this two, insert, scatter diagram. Okay, now we have here the win percentage. Okay, and that's the dependent variable, and here's the independent variable. Okay, which is yards per attempt. So here's the, so you could like NFL performance, whatever, and then you can come here and add, click here X titles, then you can type here win percentage, and you can click here yards attempt. Okay, and then also if you go here and click here, you can insert a trend line, and then in the trend line you can ask more options. Scroll down, it's not here, then you go here, scroll down, and display equation on the chart. Okay, so it's done. This is our regression equation, and this we see that is a positive relationship. Okay, that's what we have. The only difference is that this chart is starting in number 4, we start in number 1. We can rescale that if we want. If you double click here, I believe that we can click here axis options, minimum is 4. Okay, so that's the same chart we have here. Okay, so you use to understand the relationship between these two values. What does the scatter diagram develop in part A indicate about relationship? That's a positive relationship. It's a positive linear relationship. Okay. Develop the estimated regression equation that could be used to predict. Okay, we did that. Okay, but let's do that using the data analysis tool. Okay, also. So if you have the data, then you go in data analysis, regression. Okay. Y range, my dependent variable is this one, my input range. This is my X variable. I have labels, new worksheet, output, new worksheet, okay? So here we go. We have the coefficients, which are the B0 and B1. Remember, that's what we're looking for, which is the same as here, negative 70.390, negative 70.390, and 17.17. You see that is multiplied by X, okay? Let's go back. Develop the estimated regression equation. That's the same thing we have here. Provide an interpretation for the slope of the regression equation. So let's interpret the slope. Remember what the slope is? You have to remember. The slope is the B1, Slope is the coefficient associated with the X. So the interpretation for this slope is for each additional passing yard attempt, our dependent variable, which is wind percentage, this one, goes up by 17.17, okay? Again, for each additional unit of passing yard attempt, our wind percentage goes up by 17.17%. Let's take a look. The slope of estimated regression is approximately 17.2. So for every increase of 1 yard in the average number of passes per attempt, the percentage of games won by the team increased by 17.2. Okay? For this season, the average number of passing yards per attempt for the Kansas City Chiefs was 6.2. Use the estimated regression equation developed in part C to predict the percentage of games won by Kansas City Chiefs. Okay, so we have to predict Kansas City Chiefs. Let's go back to our slides. So here, let's predicting Kansas City Chiefs. The X, or the number of yards per attempt, is 6.2. Okay. So what we do is we're going to implement the formula. Which formula? Y hat is equal to this number, B0, is equal to negative 70.39 plus 17.18 multiplied by X, okay? So the Y in this case is going to be equal to negative 70.39 plus, open parenthesis, 17, that's 17.18 multiplied by 6.2. So this is the number of the win percentage for Kansas City Chiefs given this number of yards per attempt. So let's go back to the answer. The answer is a little bit different. Y 43, 6.2, 17.17, 6.2. Everything is correct here. So I question this answer from the book because we have the regression equation here. What is the regression equation? Develop, it is here. So what we have to do is replace this X by 6.2 and multiply, and then subtract. This is what we did. And 17.18 multiplied by 6.2 plus minus, that's it. So I trust on my answer and I don't trust on the book, okay? So we did everything right. Let's do one more very quickly. Let's see if I can do one very quickly. Let's work on this one. Okay, a sales manager collected the following data on annual sales. We have annual sales for new customers' accounts and the number of years of experience for a sample of 10 salesperson. So which one is the dependent and which one is the independent variable? The dependent variable is the sales that depends on the experience of salespeople. Okay, so let me open the data. And okay, so if we are asked develop a scatter diagram to understand these variables, what we can do is select these two, insert scatter diagram. There we go, is a positive relationship. The slope is not too big. We can come here, trend line, axis, and then you can type. I'm not going to type, not spend too much time. We don't have too much time. So let me solve that using the data analysis tool. If I go to data analysis, regression, okay. The Y range is sales. The X range is years of experience. New worksheet is going to be the output. Okay, so here the coefficients B0 and B1. So sales would be equal to 80 plus 480 B0 plus B1 multiplied by years of experience. Okay, let's go back, develop an estimated regression equation. We did. Here is the estimated regression equation. Use the estimated regression equation to predict annual sales for a person with 9 years of experience. So if the sales is going to be equal to 80 plus 4, open parentheses, 4 multiplied by 9. Someone with 9 years of experience, I multiply by the coefficient of 4 and add, oh sorry, it's not working, so I'll do it here. 80 plus 4 multiplied by 9. $116,000 per year. That is $1,000, yeah. So this is how you solve problems using the concepts we learned so far.